first. I'm a realist. All right. So today I want to start by taking a look at the last program. Okay. Assignment 4.1. Some things I want to talk about. Documentation. Some of you are starting to skimp. My online students actually do better than you folks as far as documentation. I don't know why. But, you know, again, put your name should go here. I deleted this student's name out. The date you're working on it, what assignment is, the class, a whole bunch of different things, followed by what is the program doing. You know, this student goes into detail, basically writing an algorithm first, what they want to input, you know, different kind of things, the input validation, creating a table, just some notes for themselves so they know what's going on. You know, and it's one of those too where in 161, I say, go grab the program that you wrote in 121 called blah, blah. And students will grab it and they'll say, I don't remember what we did in that program. Well, read the documentation. And then they kind of chuckle. Or we'll be working on 162 and they're like, I don't understand what the author's doing here. Well, look at the documentation. And hopefully when you're doing code listings, that same kind of thing is happening. All right, line 34. This was turned in before the post went up, but now we want to start putting initials in. Because out of the 21 in this class, I had 11 called payday, which means I open it to grade it, close it, then I have to go into my download folder and delete it because the next payday comes up with payday parenthesis 1 parenthesis. Then I have to start and go and clear them all out. And so one of the things that you want to start to get into a habit of is putting your initials in. One semester I had a student who was turning them in, but they weren't his initials. So I went back 2 semesters from when I was using the same programs, and lo and behold, there was a student with the initials SS. And I looked and I'm like, son of a gun, I thought they were a really good student, but they just had a friend who happened to have same class, same programs, same initials. So then I kicked him out of class. He told me his dad had cancer and he couldn't be kicked out of class because it would devastate his dad. And, well, you should have thought of that before. You know, don't put the guilt on me. You know, and then I wrote a report up for the other student who I think was still taking classes, and that did, excuse me, that didn't go over very well. Declaring variables. Do those right here in the beginning. So you know what's what, so you're not repeating them. So you're not, it's just a way to stay organized. A lot of you are using instra and outstra, every single program. So a bunch of you already have it in your skeleton, okay? Cents, days, and multi. I know what all of those are. They're the 3 inputs I'm going to need. And total pay equals 0. Well, total pay is inside of a loop. And if I don't set it equal to 0 early on, stuff that's inside of if statements or loops may create an error message that says variable may not have been initialized. So it's a good habit sometimes when you're doing these accumulators that you initialize them to 0 to start, just to be safe. Also, there are a lot of students who will do this, initialize their outstra to what's called the null string, so that we can make sure there's no other junk in there, because you just never know what's at that memory location. Okay, coming down up. See, I know right where the declaration section is. See all those dashed lines? Okay, input section. We ask for cents. We ask for numbers of days, and right away we do the bad data check, which all of you are familiar with. There are some students who are now doing integer.parseInt up here. And if you have this straight, I don't mind you combining these 2 lines. What I mean is cents equals integer.parseInt, J option pane show input dialog box, yada, 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 if that's what you want to do. Okay. But otherwise, nice laid out input section. Guess what? I know where that ends. And this is like half a second to put all those dashes in. Yeah, it doesn't take long to do. I give my out string a heading. I get inside the loop. As one student in another class found out, order does matter. Okay, inside the loop, double daily total. That means it's doing this double every time and it can get funky. So I would recommend making double, double daily total, again, using camel case and initialize it up here. Some of you will eventually take 161 and you may get into trouble in that course by doing that. Okay, but that's basically reallocating memory every time and recreating that value. Yeah, we don't want to do that. Okay, double daily total, outstra, including my formatting. This one was formatted to how many decimal places?
0.
0. Okay. Add it to daily total. Again, if daily total was the first line in this group, we wouldn't do well because we didn't change it. We would have lost some numbers. Come out, change the cents to dollars, add all of that to the string, display the string. Okay, so internal documentation. This is a real good example of the output. And I know some students posted solutions to this, so don't be afraid to get them. Don't be afraid to ask for them. Don't be afraid to go on the discussion board and say, hey, can somebody post a solution for 4.1? Because the due date has already passed. So the output, the internal documentation, and again, it takes seconds. And a lot of this you can have done early on. And finally, the initials are important. Okay, so what I want you to do now is moving on in chapter 4. I need to change my view to speaker so it can be, oh, not that one. There we go. Moving on in chapter 4, we're taking a look at running totals, which is what you've already seen. Okay, you have a running total inside of that last program, and what it does is it keeps track. It's called an accumulator. Okay, where I accumulate values over and over and over. So, you know, under running totals, I should have accumulator. Okay, so what I was thinking about and having you add totals to the program where we did the last one from class with the ones and so on, but you had to do it in the ones and the squares, but you had to just do it in assignment 4.1. And I decided to talk more about assignment 4.1 and that accumulator being in there. So the next thing we're going to do is we're going to talk about something that's a sentinel value. And I definitely know this is on 161 test and people screw it up, but it's on our test as well. It's a specific value that cannot be mistaken as a number of the list. And, you know, I'm asking you to write a program, but in a second. But if I said, I'd like you to write a program, I don't know how many people are in line or how many people are in the class because it's a lot. And I want you to find the average of the test scores. So the students are going to come up in line. They're going to tell you what their test score was. You're going to input it. Then you're going to input another one and another one and another one. And you need a way to break out. Well, a good solution for that is to have a sentinel value. So give me a number that, as far as test scores, would be a way to signify that I'm done. 23? No, somebody could get a 23.
200.
200? That's a good one. 1,000? Gabe says 1,000. That's a good one. Well, a common one that programmers love is -1. They use the sentinel value of -1. So the directions may say, please enter a test score, enter -1 when you are finished. You're entering a sentinel value. Okay. Well, here's an example. Write the code to find the average age of your classmates. And so we're going to keep inputting numbers until a 999 is entered. At that point, you're done. You're gonna get out. You need an accumulator to keep adding up the number of students' ages. And then you're gonna need some sort of counter to keep track of how many there are. And then when you jump out, you take the accumulated value divided by how many students there are to get the class average. Are there any questions? So for
What if you
this
do-
one, go ahead.
What if you do so bad on the test you get a -1?
Then maybe you ought to make it negative 1,000 or something. I don't know. That might happen. All right, so I'm going to pause the recording. Thank you. Okay, so Anthony's still, quit typing. Oh, I see what he's doing. All right, so up at the top, declared all his variables. Don't watch what he's typing, watch up top. Anthony has his own style. This is a conversation we were just having in that group. The end of line 12 and end of line 13, he likes what the author does and puts the left brace at the end of the line instead of lining them up. I'm a big proponent of lining them up, but he called a personal preference, and okay, you can leave it there. All of his variables,
Is it more difficult for other people to understand or read?
I don't know.
Because that is a very valid criticism.
So go scroll down to line 26. And here's our do loop. We input a string, we ask for an age, okay? And we take that age and convert it to an integer, okay? And if the age equals 999, it's going to actually kick us out of there. Now, what else? Hang on one second. I have a student taking a test and I need to put him back in the breakout room. And there it is. And he's gone. Okay, so inside of here, we have, we add the age to the total and we increment students and off we go. So before Anthony keeps typing, what's wrong with the logic up above? From lines 26 to 32.
Is it the kind of loop that he's using?
Increases the number of students even if the user doesn't enter anything.
Yeah, if they actually enter 999, that's getting added to the total age and the number of students is incremented. So this is going to be bad. So the way he would have to fix that is with an if statement at line 29.
But doesn't that defeat the purpose of its interim value? As in, doesn't
Okay,
that just make
then let's
result in
switch.
redundant statements?
Let's switch it around. Delete out line 26. Delete it. Okay. Go to line 29. Go to the left 3 spaces. Do this. While.
Yeah, you want to do while.
Parentheses what? Anybody?
It's while age is not 999, right?
Right, not equal to 999, parentheses, left brace. We're going to have total. We're going to have student. After student, hit return or enter. Now, line 27 and 28, copy it and paste it inside of your while loop. And get rid of the big part of line 35. So we asked for it before we even get into the loop. This takes care of that running 0 or more times. A while loop would be definitely more appropriate here.
This works better.
Right. The do loop would work. We would just have to put an if statement in there to make sure we don't add the 999. Either that or when we got out of the loop, subtract 99 or 999 and subtract 1. Okay. So my initial value is line 27. My check is line 29. My increment slash update is line 34. Now he's doing a check to make sure because of the division kind of deal. But he can keep playing if he wants and upload it. That would be fantastic. At this point, we're gonna move on. Okay, so I'm gonna take a little power and I'm gonna steal the screen back, not have him stop sharing. All right, the next thing we're gonna take a look at is something called a nested loop. Just like we had nested if statements, a nested loop is a loop inside of another loop. And I'm going to take a look at a couple examples here. If I have a for loop, I could have another for loop inside. I could have any combination of loops. I could have a for loop on the outside and the for loop on the inside. And we start to use terminology where this is the outer loop and this is the inner loop. How many times does the inner loop get executed? How many times do I do this line of code? I bounce up here, right? This for loop says, do what's below it how many times? Counter 1, less than 12. What's the number here?
11.
11, right? You can almost see I have where I erased it from last time I used my notes. 1 to 11. Okay, so that means I want to do this for loop 11 times. Okay, inside of this for loop, all I do is say, hi, mom. How many times does this for loop run? This is counter 2 equals counter 2. Well, you can sort of see it from before, right? It runs 5 times. So how many times will hi mom, if that's in the body of this for loop, get displayed? Well, let's see.
It will be like 12 column and
All right, I'm going to do this, counter 1. I'm going to do this, counter 2. Now, as I go through this, my outer loop starts at 1. What values does my inner loop get? Well, it gets 1. Outer is still 1. This is 2. Outer is still 1. This is 3. Outer is still 1. That's 4. Outer is still 1. That's 5. So this guy looped around 5 times. Now it's done, so it kicks back out to the outer loop. 2. Now I redo this. 1, 2, 2, 2, 3, 2, 4. Okay, so that's the values of counter 1 and counter 2. Each time inside of here, I'm displaying hi mom. System.out.print hi mom. So how many times would hi mom get displayed?
60.
11
60,
times
11 by
5,
55.
55, right? 55 times. So 11 times 5 is basically what happens. Now, the question that just came up in the other group is they're writing this last program. Could they have just used system.out.print for their program? And I'm like, yeah, because this is a learning moment. And if you want to just display it in the console, that's great. That's where it's there. It's there for the programmer to do, quick ones. And then, okay. And okay. That's an infinite loop.
Sorry, though.
Somebody broke out of my infinite loop.
There's glitch in the matrix this morning. What can I say?
I know. Okay. So, use the system.out.print if you need to, while like the last problem we were just working on with the averages. Go ahead and use the console. I'm okay with that. Next example. If the body of this said something like, hi, mom, again, how many times would it get displayed? What's my outer loop run? How many times?
3.
3. Inner loop, how many times?
3,
3. So 3 times 3 is
9.
9, right? Okay, so we, as you know, can take all kind of variations in a for loop. I mean, I might have a for loop that says I equals 10, I is greater than 6, I minus minus, that's one loop. And then my inner loop might be for j equals 1, j is less than 4, j equals j plus 2. Ha! Don't know why I might need i's and j's to be different values like that, but how many times would this loop run? Outer loop works for, I would get the values of 10, 9,
9, 8, 7.
8, and 7. The inner loop each time we get the values of 1,
3,
3, and that's it. So 4 times 2 would be
8.
8. Very good. Very good. Okay. If you're not sure, why not do something like this? Put in system.out.println I, and then some spaces, and J. And you could actually see 10, 1, 10, 3, 9, 1, 9, 3, 8, 1, 8, 3, just like we were doing over here when I was hand tracing it. Okay, pretty easy, pretty good. When will I ever need it? Well, here's an example when. Rows and columns. If I think about 3 by 3, right? 1, 2, 3, 1, 2, 3, 1, 2, 3. What am I looking at? Maybe a matrix. I got a matrix. Maybe tic-tac-toe. This is something's coming up in chapter 7, where we're going to get a bunch of actually really good use out of for loops. All right. What's the surprise? Write the code to display the following. Shnong. Shnong. I want you to write the code to display these numbers. And since there's so much trouble with the internet, why don't we just have individuals work on it, and then we'll go from there. Any questions?
Display those numbers or that pattern?
These numbers. That's extra for experts to make a pyramid like that. Okay,